All right, back to it. A little bit of Unreal and C++, just a little bit of learning, nothing crazy. And so we're saying we have this array, it has some amount of indices, and this is saying for num in this, do something with this guy. So could this be so simple? Whoa. Each element in this, and we're okay. The only thing here is I'm hoping that this isn't copying each element. This isn't assigning that element to here, because what if this was an expensive object? A big array of big objects. And now we are copying a big class by value to here, and then doing stuff with it, and then copying the next one to here. I think it said it was accessing it by reference. So it's probably doing something like this is being set to be a reference of this index, which should be cheap. And then we're simply accessing it as or by reference. The value of the current array element will be assigned to the variable. That's the sketchy part right there. Should at the same time makes sense. Otherwise, we get some implicit action. Sure, we can do the same thing here. Fibonacci integers. Okay, sure. 0, 1. Oh. Oh my god, that's delicious. Only thing is we don't have any checking here, right? Or what if we said oh, okay, so we can still evaluate on it makes sense. I just can't do it on the loop variable. Like if I had a loop that was counting up with a loop variable, and I wanted it to be careful starting at 5, I wouldn't be able to say that here. I'd have to specify the value that we need to start being careful, which maybe makes sense. Live stream and vector, boom. Yep. And we're doing spaces in this case. And at the end, an end line. Oh, good little bridge. Cool. Time is still ticking. Num is assigned to the... Well, num is assigned that value. Makes sense at the first. Then we do some stuff. And then we assign the next. Again. Excuse me. For each one until there are no elements left. And then it ends. Cool. Num is not an array index. It's assigned the... Well, duh. It's assigned the value being iterated over. The only thing is I'm worried about that repeated assignment over and over to the same thing. Fuck. Yep. It is indeed assigned the value. And it does mean that the array element does get copied. So this is for cheap ones. Cheap. Vectors of cheap types. This is for traversal of cheap containers, seems like. It just won't execute, okay. Won't print. Type deduction, huh? Also, we could say auto and it would deduce the type from the elements indices? Elements? Or from the array's elements, rather? Maybe I'm just stupid, but I kind of enjoy the redundancy so far. So far, I'm an anti-type deductionist. Or a type deduction antagonist. Rejector. Hater. Type deduction hater. It's cool that if it says int num, then we know that, oh, hey, even if Fibonacci is declared elsewhere or as a global or something, we know what type it is. I mean, we could find out with the IDE, sure, hover over, and then it should deduce and tell you. If known at compile time, which it should. I don't think you can change the type at runtime. Yeah, because we can't have a template type in the function, I don't think. Really? Okay. Well, if we want, okay. If it's ever updated, it's the same. Okay. That seems rare, but sure. Oh. Yeah, now we're copying a standard string each time. Oh, nah. Yep. Or by string view, because those conversions are cheap. And it makes the function able to accept more types of standard strings instead of it having to be a standard string reference. Oh shit, nice. So you just make it a const auto reference? Oh, so then we're just assigning the index to this guy via reference. That's good. Then we're just, the only cost is making the alias over and over, which should be, I don't know, 0 maybe? Cheap, hopefully. Hello? Oh, oops. Nice. I couldn't tell if I saw a difference in processing time, but it shouldn't be with how tiny this program is, but I thought I noticed it. It was just a coincidence. Nice. Sick. Yep. Oh. Uh oh, hold. Oh, hold. It's because these are, wait, what? Hold, wait, what? Oh, oops, sorry. I was passing it via const reference. That was the issue. Okay. Ooh. Ambiguous because it could mean a conversion to... Well, shouldn't there only be one thing? Values being assigned. It doesn't know whether to convert it to this or to convert it to a that before converting it to a string, I think. Oh, okay. Oh. So not using anything that's only runtime like this. When to use auto versus auto reference versus const auto reference? I mean, we could use auto if the thing is cheap and negligible, or auto reference to just be more efficient overall, or const auto reference in that case. Instead of auto, it feels like we may as well just use const auto reference because we can't change the object anyways. We can still assign the value to other things. Const auto reference seems like it's cheap regardless of the type of object, and then auto reference if you want it to be mutable. Yeah, I agree with const auto reference because then we don't have to change anything if the type changes, especially if we're using a template function. Oh, I was reading down here. Template or function template, and then a template function. Gotcha. So in this case, I had made a function template from which the compiler instantiated template functions. Specifically, one that accepts a standard string. Vector of standard strings. Well, I mean, const auto reference, unless we're talking about blanking something out. In that case, we'd use auto reference, but in this case, consider this example. If we pass this, and it auto, it's expensive, and well, it's not necessarily expensive here because we're talking standard string view. But in the case it became standard string, then we would need this to be a const reference. But if we wanted to blank it out, then we would need auto reference. Or just standard string reference. But for template auto, I get it. Boom. See? Now it's going to be expensive, 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 expensive. And those are. Yeah, and if we update. Yeah, so if we're going to say, hey, we're changing this data type, okay, but we might not know that, oh shit, we already have type deduction going. See, and this is why I don't like the type deduction as much, because auto, it feels like it's easier to miss out on the reference or const for auto than it does for a standard string. Because I can see, oh, hey, these are a bunch of standard strings. I hope that I am, when I'm using this range-based for loop, or this for each loop, that I'm using a const reference, or at least reference, to look at these one by one instead of assigning their values. Well, let's check. Oh, it says auto. Cool, right? No, it needs to be a const auto reference. I mean, maybe this doesn't make sense. Excuse me, but and if we start with a const auto reference, then one, it's future-proofed in terms of type, and two, it's also future-proofed so that the only time we actually get an issue is if we need this thing to become mutable. That's all. Yep. Wish you didn't tell me to use auto in it, you fucker. Like a standard string view can accept and get a view regardless because it's already operating via pointers. Makes sense. Because now each time it's being well, yeah, because if we're not doing it by reference, now we're converting each value to a standard string view instead of explicitly just having a reference of whatever the type it is that we're doing. Oh, the point is if we want to get it by value and update there, I would rather just say, I mean, at that point, we may as well just use const auto, and then if we really need to change it, make it, well, I mean, I guess there's redundancy there, but if we made a reference, and yeah, you know what, yeah, sure, that's fine. It just depends on what we want to do. Yeah, I agree. I was going to say we could make it const auto and then make or auto reference, and then make a variable that gets assigned the value from that if we really need to change a copy of the value. But in that case, if that's the use case, we may as well just remove the reference so that we're not creating references over and over again. Just make the copy if you're going to make the copy. Instead of charging a cost of 6, just charge a cost of 5. Sure, 1 is not much more than that. 6 is not much more than 5. It's only 1 higher, but still. Other standard container types. Non-decayed. Ooh, linked list, meaning pass a linked list and it goes through all the separate little places. Interesting. Yeah, true. No idea about any of these. Nice. More than standard vector. Cool. A standard array. Auto. In this case, we're still getting copies here. So maybe we don't want to make copies of the integers, especially if we're just printing. I mean, I guess it's the same, really. Not decayed C cells. Oh, because if it's decayed, it's a pointer to each thing, and it doesn't tell you anything about the rest. It just continues until, I think, the endling character. Also won't work with enums. Fucking hello? Oh, meaning if you have a standard array of, or an array of enum values. Interesting. I'm surprised though, because it should be just a type definition. We should be able to define a type of the enum and assign the value or get a reference to it and then do that. Are you sure? Let's see what happens. Need vector. Our stream needs standard character output. Okay, and we'll say, let's say we have a enum Pokemon types. Pokemon type, and we have fire, water, grass. Okay, the main 3. Metal's cool too. Okay, and we have a standard vector, of Pokemon type. Types, and it's fire, water, grass, metal. And yeah, better to have this be scoped so we don't get name conflicts, but it's fine here. For types, hold on. For Pokemon types. We could just do a switch. That's cap! Range-based for loops also won't work with enumerations. Are you tripping? Unless standard vector is an exception. I don't know what you're talking about, yo. I just used a range-based for loop. I just had a standard vector of an enumeration. I don't know about that. Getting the index of the current index. Do not have a way, not a direct way at least. Many of the structures that a range-based for loop works with do not support indices. Yeah, like why would you? You may as well, right? Only iterating forwards. However, you want to traverse and reverse. Forwards to 2020, range base could not be easily used, and other solutions have been employed, like a normal for loop where you just decrement instead, and you start at the last index. But instead, hello? Oh, standard views, meaning you get a view to what, like a temporary string that is a reverse of it? Interesting. So, what is it? Standard ranges view or something? Standard views reverse. Do I need anything specific? Uh-oh. Ranges. God damn it. Oh. $30, 20, 10. Oh. Reverse. Reverse underscore F. I wonder what those identifiers are. Is this just a using? Like using standard views reverse as reverse N? Or reverse underscore FN? And I don't know what this other shit is. Standard ranges view. Is this a fucking lambda? I don't know what that is. It's in alphabetical order. Now we count down from reverse alphabetical. DCBA, okay. Consider this a useful bit of magic for now. Oh, this guy's great. A standard vector with a bunch of names. The user enters a name in a range-based for loop. We'll check. Bop, bop. Megatron? Okay. Alright, I don't give a fuck about these hints. Hold. Why is there a hint there? Okay. First, I know we need string. Need standard string. And we need a standard string user name, and we'll just say whatever, it's nothing. And then we also need include an iostream, need standard character output, enter a name, and then we also need standard const standard string names. Oh, actually, sorry. This is we also need a vector here. Include vector, need standard vector t. Brain is fucking dying. Excuse me. We're gonna do a const standard vector of standard strings called names, and it is Alex, Betty, Caroline, Dave, Emily, Fred, Greg, Holly. And then use a for loop to see if it's in the array. Okay, and then we'll do for const standard string. Well, I mean, if you want, sure. Auto or const auto reference name in names if, well, let's see. And the point is we're saying enter name Betty, Betty was not found, enter name Megatron, Betty was found, Megatron was not found. Okay. I mean, this seems like a stupid way. Bool name found nothing. And then we say if username, or well, if name is username, then name found is true. And break. And then if name found username found, else username not found. Oops, hold. Also totally didn't extract it. Oh, what am I doing? Getting character input to actually get characters, and we're ignoring standard whites, or well, and there's some operator overloading for this guy, so that if it takes a standard character input and a white space, that it ignores the white space, something like that. Betty, Megatron, yo, Holly, Alex, cool. Feels like a shit way. Because I want to execute this whole thing, and then only if it wasn't found. Like, we could print found the second it's found inside the range-based for loop. But if we go outside, there's no if. So we say, okay, we have our names, and then we have username, and then we have the prompt, and then we're getting the name. So we could say name list, get username, name found, check if name found, or we'll find name, name found. Feels too long. First bit's okay. And in here we could say we're comparing the username to each of these. So we're saying for each of those, for each name in names, is the name username? If it is, set found and break. So it'll be nothing, nothing, found, set true, break. Is it found or not? Because if we print found the second that it's found, and then break, then how do we print not found? I mean, we could say, I mean, that's really it. We have to have this, and we say name found and break, and then we could say if not name's not found, maybe we could say, I mean, I guess we can get rid of some redundancy, right? In this case, we say, right? And we get rid of basically a line or two. Okay, say the name is not found, and this is value initialized, but we'll just show that it's false. Okay, name is not found by default. Is the name found? If it is, print that it was found and break. And then, if it wasn't found, boom, print this. Well, I mean, I'm doing a const auto reference, but you could also do a standard string. How would we do that if we did a standard string? If we did a standard string view, right? We're doing standard string view here. And what is this going to be? A fucking thing of standard string views? I mean, could also be. There's different ways of doing it. But then we can't assign to a standard string view. So this needs to be string. And then I don't know. That's fine, I think. I fucking told you. Mine's smaller too. Well, minus 4 lines, so same, 31 lines. Yeah, but you could also just do a const reference too, and then it would still not be making expensive copies. You could do this either way. Yep. And then at the end we could do this, or we could do it there. I don't really care about which version. I like the first because this way we show that, hey, found, and then we say when we're found. And honestly, I actually prefer that. Modify your solution. Hold. A function template called isValueInArray that takes a vector and a value. Well, I guess we're finishing it tomorrow. Okay. Oh. Oops. Fuck, I need another solution. You know, I'll rewrite this tomorrow. I'm all about getting the hours in. which can be indexed using, I need to get back to talking, just thinking really hard, which can be indexed using a signed variable. Basically, the point is we could do some conversions where we have an unsigned loop variable and plug it straight in and we're cool, unless we're decrementing, because then if we're saying, hey, as long as it's greater than 0, blah, 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 do some shit in the decrement, well, eventually when we get from 0 and we decrement again, and it would get, oh, -1, -1's below 0, stop, nope, we get underflow. So it wraps it back around to the maximum value of an unsigned int, which is like fucking 4 quadrillion or something. It's an infinite loop, and we access out of range. What we would do, what we could also do is do a we access out of bounds. We could use a signed loop variable instead to avoid that, because then once it's negative, it knows that it's negative, the value is negative, and then the loop stops. But then we have to convert back, we have to convert the size of the array to, or we'll get it as a signed value or convert it to a signed value from an unsigned value. But then we have to convert it back from a signed loop variable to an unsigned via static cast to actually index the thing. Or we could just use the data member function of the standard vector of the array, because I think standard array is the same, maybe. The data, which I guess yields its data in a C style, in an undecayed, so that has the whole, it's still in an array form, the undecayed C style array. And those accept signed and or unsigned and signed indices. Excuse me. Oh. Wait, it's okay with that? It's okay with the literal? I'm surprised. Oh. Okay, it does need to be before. Alright, my first guess is correct. That's nice. Next, we have test. Let me call. Oh. I wonder why it's liking that. Still! I give up. I don't understand. Okay, bro, what the fuck am I waiting on right now? And it just crashes? God, suck my dick, bro. Fucking why? Computer's old, but it's not that old. Oh my fucking god. Let's see what's wrong here, huh? Friend class is a class another class has declared as a friend, letting it access the friending class's private and protected data members. Friend function is a function that another class declared as a friend, letting it access its private and protected data members. This could also be functions too. Static member variables are variables declared. Okay, I'm getting tired of this. Declared in a class definition and defined outside of it unless inline. All objects of the all instances of the class share the same static member variable, which exists in one place in memory. instance one definition, either one included in multiple places but deduplicated by the linker because inline, or one place because defined in CPP file. Changes to the static member variable are reflected in all, well, when checked by any of the class object instances. Static member functions are functions that cannot access non-static member variables. Classes non-static member variables and can be called on an object or ideally by resolving the class's scope. i.e., use them to update the static member variables. Well, I mean, could do it either way. I don't see a huge amount of use for them right now, but, well, yeah, sure. Like updating the round health bonus that all zombie instances get. Destructor is a function that gets the member function with the class's name and prefixed with tilde. Oops. Uh-oh. Gets called when the class object is destroyed, i.e. when it leaves scope to be destroyed or is destroyed by other means. Perform cleanup on anything. Well, what do we even want to clean up? Cleanup needed when the object ever destroyed. Split classes into header and source files to keep header files cheap to include. Concise and readable. And concise and readable. Is that it? One, they're cheap to include, and concise and readable. And modular, with definition in the header, and well, with class definition in the header, but it's larger member function definitions in the .cp file. Or non-inline static member variables. But this pointer is a pointer to the implicit object. Class object itself that the compiler passes as an argument to all of the class objects, or to class objects member functions. Letting the member functions access data members through this pointer. That it, and friend member functions, or and friend member and well, also return the dereferenced this pointer for member function chaining, and keep in mind that this pointer is const if the function is const, or well, the const. So calling a non-const function chained after a const member function will work. Since we'd be calling a non-const member function on a const implicit object, right? Class tests. Let's see. Void thing 1. Void thing 2. Haven't decided what I want to do. Const. Return this. What's one thing? Hold. Fuck, what do we even return when we do this? Do we just return a test? Guess we do, huh? And I guess, I mean, it should be valid, right? So we should be able to return a reference. Uh-oh. Oh, hold. Okay, I don't know why it was having an issue there. Oh, my eyes are falling asleep. Fuck. Oh, my eyes are going. Can you see them? They're just done. Fuck, I haven't gotten very far. 5 more minutes? And then the answers? Alright, so we should be able to do the second and the first. So we could do test x dot hold. Why the fuck can't we do it? It's inaccessible. Oh, duck, it's fucking private, but oh my god. I might have done that earlier too and forgot. Boom. But. Oh, it's actually okay with it? Oh. What if we had... Still, it's still actually okay with it. May not work if the non-const member function changes data members. Mutates data members, I think, something like that. I'm not exactly sure when it is an issue because I just tested it and didn't see an issue just there. 26, explicit prevents calls to the constructor, or constructor calls with implicit conversions. Define constructors that can take one argument as explicit to prevent any danger of uncertainty of these conversions. Excuse me. Copy elision, perhaps mandatory, is when the compiler optimizes away copy constructor call or calls to the copy constructor. Redundant calls to the copy constructor. Hey, when passing, let's see, so if we pass an object by value to the constructor, and then, or hold, we call the copy constructor, or we call a function and passes something by value, and then it assigns another with that value as the copy constructor. Well, the value's already in there. The object's already in there. There's no sense making another entire object. Right? When passing a class object to a function as an argument, as a function argument, that is used to initialize another class object via copy constructor, then returned as a by value, the another class object copy constructor call might be elided because we already have the past object in the function, so copying it to create another is redundant. 24. Member initializer list is the initializer list that a constructor uses to initialize the class object, its class object's data members, which is required for const and const expression objects since if they were assigned value in the constructor body instead, they'd already have been default initialized by then. So the assignment would fail due to their constness. Okay. Constructor is a class member function with the name of the class that is called when the class is instantiated. When a class object is instantiated, or well, when the class is instantiated by creating a class object. It uses a member initializer. I keep saying list initializer. Initializer list to initialize data members. And the body to perform setup and preserve invariants. It's different because it has no return type and shares the class's name. Okay, 122. Public members are accessible to the public, like main, and anywhere the class is in scope. In any translation units the class has been included in. Private members are restricted to objects of the same class or friend member, friend non-member, friend member or friend non-member functions, or friend classes. This upholds encapsulation where public interfaces, I hate passive voice, whatever, are used to access or to use classes instead of implementations, which can change and are more complex. This makes making classes easier to use and simpler. Simpler and safer, since invariants are preserved privately. Bop. Oops. Bop. Give me the answers, yo. Check me out, huh? Give me some of these fuck ups. Tell me. That was gonna be a while. Uh-oh. Needs expansion. Oh no. Uh-oh. Hold. Uh-oh. Oh, I'm fucking up. Here we go. Good. Good. Alright. Basic syntax for range-based for loops. It goes through all good. Okay. They also work on meaning other containers, not just standard vectors. Not even just arrays. Standard vector is still an array. List maybe is an array? Okay. Any type with begin and end defined? Oh, I guess they have member functions that I haven't seen. For non-copyable and expensive or usually necessary, it doesn't have to iterate forward. The order actually depends on the container. Well, I was told that the range-based for loop does iterate forward, but okay, for these it's forward, okay. Returning standard vector from a function, returning by value with move semantics is the usual way. Const reference is only safe if the lifetime expands. Well, and that's what I meant. If we're saying that we pass something as an in parameter and we're also returning it, well, if it's passed as an in parameter, we know it's valid outside the call, so we can return it. If we return it to a local variable, sure, one that was actually created in the function, duh, we get a dangling reference. No, sir. Bad. It's destroyed. The reference now refers to nothing, and it's undefined. It's only valid if it's static. Yep. Which is exactly what I said. You dummy. Return my value. Okay. RVO/move. I don't know RVO. All right. Example. We have something that returns it not by value. Well, actually, dude, this is the exact example that I used. I said pass this in, and you're saying return it by reference, and I'm passing it in by reference. That's exactly the case that I said, but okay. Passing a standard vector to a function by const reference, cool. By reference to allow mutation. We could also pass by value if we intended to store it extra in there. Sure, maybe. Some overcomplication. Oh, okay, good. Sign and sign mismatch, possible overflow. Well, underflow in this case, really. Or existing outside of bounds. Fill off signed. It still expects a size the index. Fake news, buddy. Wrong. The cleaner fix is simply get the size type or just standard. I mean, we could do either way. Size type or cast loop variables explicitly. I don't know what you're talking about. Cast loop variables explicitly? Well, yeah, that's the same thing we did. I don't like saying vars. Okay. I mean, you could do standard size T. We could do that to get static cat. Yeah, I get this. I understand this. Yep. Vector with that. Correct. Standard vector provides contiguous storage. Oh, because it's bop. It's not separate like a linked list. Amortized. Oh, one time complexity. So if it's even bigger, it's still the same. Should be. Same cost, no matter what, hopefully. Or same time, at least. Correct and explaining. References that for that. Missing. Ref qualifiers go after the function's signature, but before the const. Hold. They don't accept. They control which object category the function can be called on. Oh. Hold. What the fuck are you saying? Oh, that's right. Oh shit, this is great. I was wrong. It is that it determines so the syntax is correct. It's just that it's not about receiving something, it's about what it can be called on. So if we have a class and we have a gun and we call something on, the problem is that I created an L value class and it didn't matter what I was passing the member function, it was always called on the L value. But if I had called a function that returns a temporary, or I had just created a temporary one, but I don't think that really works. Well, yeah. Okay, let's say in parentheses, I created a temporary class of whatever, and then we do dot something. Well, if we do dot something and there's an overload with ref qualifiers, then it will call the R value one because it's a temporary. I understand now. Thank you. This stuff sticks in my memory because before I vividly remember getting the unline or the unnamed and inline namespaces wrong. So, but now they're in the brain forever. Simple, or at least for now. Simple and accurate for those. You have to find that out. Friend functions are not member functions of other classes, motherfucker. Oh, and friendship is not. Oh, yeah, true. Friendship is not inherited. I don't even know how inheritance works, but I guess if you create a class from another class, it's somehow inherited. That friendship doesn't go down to the smaller, the child class. Nor is friendship bidirectional. Static members, how far did we go? Oh, we're not even that far. Oh, never mind. Okay. The key initialization point. Static members must be defined outside the class unless declared inline. Motherfucker, that's exactly what I said. So that we say in the class, we say static something, and then we define it outside. Bro, I cannot with you. I cannot. The destructor, the tilde, is followed exactly by class name. That's also exactly what I said. What the hell? Though I said nuance, if we have a const object, hold. Oh, this wasn't called const. I think this needed to literally say const in order for it to not work. Okay, because I called the non-const and it didn't work. Chaining or not, okay. Oh, the object needed to be const, okay. And the point is that I think we needed to return a const this to make it not work. Okay, I'll try that tomorrow. Explicit constructor prevents accidental conversions. Okay, it seems like that's just the point. We're just calling it with... Okay, just to make sure that it's initialized properly, basically. Population. Many cases are actually mandatory. Hold. When passing a class, then return by value that's not. That's invariant. That's named return value optimization. Copy illusion also occurs in return my class. Temporary object where no copy. Wait, what? Oh, wait, no copy or move is made? I don't know how that works. Okay. It's not user vote. NVR, NRVO? I don't even know what that is. We haven't heard about that yet. Points about constant avoiding default and assignment. Makes sense. Can assign in the body. Well, yeah, I said that. I just said that it's required for const members and const expression members that we can't assign them in the body. And then, cool. Okay, sounds good. Sounds good for me. All right, back to learning Unreal and C++ together. Bop and bop. Bye-bye.